Hello everyone. I'll take you through a quick example here to clarify things out before we proceed with the animated code. You are given an integer array nums. This is the array consisting of n elements. We have 6 elements, and an integer k equals to 3 in this example. Find a contiguous subarray whose length is equal to k that has the maximum average value and return this value. So we will go through each subarray and nums in the array nums, which its length equals to k, which is 3 in this example, and get each subarray's average value, and among them all we should get the highest or the maximum value. So in this example, when we go through nums, we will collect the elements 2, 1, 5. Now, this subarray length equals to 3. So we sum the elements and divide them by the subarray's length, which is 3, and then we get the average value. We will repeat this for every 3 elements or subarrays, which length is 3, and get its average value, and we will go through all the values and get the maximum average value among all the subarrays. So as I said earlier, 2, 1, 5 is the first subarray. We drop the 2, we go 1, 5, 1 is the next subarray. We drop the 1, we go 5, 1, 3. It's the next subarray, and then 1, 3, 2. This is the last subarray. So we get each subarray's average value, and then we get the highest value among them all. That's it. Okay, so first we initialize max average with negative infinity. This is because we can have negative average values, which won't work if we set it to 0. Because we will get the max value between max average and the sum divided by k, which will result in a 0 if sum divided by k equals a negative value. Now we go through the array minus k plus 1. I'll tell you why in a second. We will set sum to 0, and then we'll go through a window at the current index till index plus k, which is why we took off k plus 1 from the array length. This way we'll be able to calculate all the average values in the array without going out of bound. After we finish adding the values, that is, adding all the elements in the window, we'll calculate and save the max average value. If max average is greater than sum divided by k, then we'll keep its value. Otherwise, we'll save the new average value and consider it the maximum value so far. Now we will repeat, but we will drop the first element by advancing the current index and go for another window. Now, I'll leave you with the animation until the problem is solved. By now, you should be able to see the inefficiency of our repeated calculations. I think we can do better. You can double the speed to watch this algorithm as it solves the problem, or skip it if you get the point. Okay, so here is the efficient algorithm to solve this problem and reduce the repeated calculations. We introduced a new variable, window start, that will keep track of the start of the window and rename sum to window sum. You'll know why in a second. Here we'll go through the array in one go. Renamed IDX to window end. So window end will keep track of the end of the window. Now we'll add the current element to window sum. Then we'll check if we have a window of k minus 1. That is, window end is greater than or equals k minus 1. Why k minus 1, you might ask? Because indexing starts at 0, so we'll have to take that into account. If at any point window end is greater than or equals to k minus 1, then we have enough elements in our window to get a new average. At this point, we calculate our new average. Take off, that is, abstract the first element in the current window, which is exactly where we need window start. Because window start keeps track of the index of the first element in the window. Now we increment our window start to keep and mark the next index as our start of the window. We will keep repeating that until we get a solution. But notice, this algorithm is way more efficient than the other algorithm, which has a time complexity of O n times k, compared to the current algorithm's time complexity of O of n. And that's it. I'll leave you with the animation. You can double the speed if you get the point.